A simple battery or galvanic cell is made up of two half cells. Half reactions are either oxidation or reduction reactions happening inside the half cell. A piece of metal inside of each half cell is known as an electrode. The electrode that is being oxidized is the anode, and the electrode that is being reduced is the cathode. The salt bridge is made up of electrolytes, and electrolytes are a gel that contains ions. The salt bridge also balances the two cells. The battery works by an electron moving from the anode to the cathode, which produces a charge. The first step in building a battery is to identify your anode and cathode. This will help make everything easier from this point on. The next step is to pour the solutions into their respective beakers. Step 3. Insert the electrodes into their respective positions. The anode in the anode solution and the cathode in the cathode solution. Step 4. Add in salt bridge to balance the equations in the two half cells and complete the circuit. Step 5. Attach probes and record voltage. Congratulations, you are now the proud owner of a new handmade battery. Oxidation occurs when an element gains a charge. The oxidation equation shows the element that is being oxidized and the electrons that are released. The oxidation number stands for the number of electrons lost. The oxidation equation shows solid aluminum yielding aqueous aluminum 3 plus 3 electrons. Reduction occurs when an element gains an electron and loses a charge. The reduction equation shows exactly which element is reduced. The reduction number shows the amount of electrons gained. The reduction equation shows zinc 2 plus 2 electrons yielding solid zinc. The cell potential is equal to the voltage generated by the galvanic or voltaic cell. It is determined by flipping the sign of the anode and adding it to the cathode. The voltage generated by this cell is 0.897 volts. KNO3 is typically used as a salt bridge because all nitrates are soluble and potassium is always soluble as well. KCl would also work for the battery because the voltaic cell does not use silver, mercury, or lead. If those elements were used, the battery would form a precipitate at the bottom. A battery will stop working when an anode withers away, the salt bridge dries out, or the concentration of the cathode is decreased. Rechargeable batteries work by taking the reactions done inside a battery and reversing them to the previous state before any reaction occurred by applying the current through the charger to the battery. The only time a rechargeable battery will stop working is when the salt bridge dries out. The constant of the anode solution increases over time because the electrode slowly withers away, increasing the amount of Al3+ available in the solution. The concentration of the cathode solution decreases because the Zn2+ joins the electrode, increasing the number of Zn0, distancing the ratio of NO3 to Zn2. If the metals were switched, the aluminum would exchange places with the zinc in the zinc solution. However, no reaction would occur in the aluminum side because aluminum is higher on the activity series, but because no reaction is occurring on the aluminum side, the voltage would be 0. Over time, the anode will wither away and become part of the solution as Al3+, which will increase the concentration and improve the quality when the electrode is replaced. The salt bridge will eventually dry up, and at that point, it can no longer effectively balance the equation and complete the circuit. The cathode will draw solid zinc from the solution, decreasing the concentration and growing the electrode thicker.